Hi friend, I am Sanjay. I hope all of you are good. In this video, I shall discuss on fan coil unit or FCU modeling in HVAC system. Also, I will show you how to generate quantity quickly in Revit along with its shear parameter. So without wasting any time, let's go. Before I start the modeling, I want to tell you the basic working principle of FCU. So in FCU, three duct systems are connected. In the supply side, cold air is entering or diffusing to the room, and in the return side, FCU is collecting the air from the same room, and in the air transferring process, we lose some air quantity. So to make up this air, we need fresh air duct to balance the air in and out to the FCU. And this fresh air duct we can connect to anywhere in the return duct. So as per this concept, FCU have two duct connector. Air outside is the supply and air inside is the return side. And FCU have two chill water connector, one for chill water supply and another for chill water return pipe. These chill water pipes are connected to the chiller. During this heat exchanging process, some condensing water have been produced, which is collected to the drain pan and finally to the drain pipe, which is called condensing drain pipe or CDP pipe. So for FCU we have three pipe connectors, two for chill water and one for condensing water pipes. And for electrical connection, one small box setting is there in FCU. So now you can understand that FCU is a mechanical equipment. Fresh air is connected to the fresh air handling unit. Chill water pipes are connected to the chiller. Condensate drain pipe is connected to the drain pipe. And for electrical, one BMS and one power connection is there in the FCU. In market, there are so many FCU makers and suppliers. Let me show you Maker FCU catalog, which I mostly use. This is Maker 09MKHS series model, where these 7 kind of unit sizes are available. You can check in the casting the original looks of FCU. And inside the FCU, these heat exchangers copper coils are there, which is connected to the chill water connection. This is the air filter, which filter the return and fresh air duct entering the FCU. This is the fans through which supply air is entering to the room, and this motor fitted to the fans, and this is the drain pan below the coil collecting the condensing drain water. And finally, this is the FCU dimensions, and according to the model, dimensions are given to this table. You can check for every model. L-A is 120, A minus B is 40 and H minus I equal to 40. So it means all the model sizes will increase or decrease within the scale factor. Now let me open Revit. In family section, click new. Then select metric mechanical equipment family template. Let's save the family. First, I shall model the maximum edge parts of FCU. You can check these two parts are maximum. Here in the plan, top edge parts dimension is A, and in the table for model 921, A dimension is 1014 and width is 650 mm and height is 275 mm for this FCU. So let me model this part in the Revit. First, I will do extrusion of this part as per Fcu 09MKHD 921 model. Then to equally increase this model from reference line, make dimension and click equal. Then to assign these dimension with parameter, click parameter properties, name A, click instance, then OK. In the same way for width of the Fcu. Check the parameters in the family type. You can check sizes are changing as per parameters. Now let me draw the supports holder holes in the Fcu as per catalog. Here you can check I lock the dimension as these dimensions are same for all the Fcu model, and lock the edges to edge dimension as these support holder will move as per Fcu model sizes. For your information, after every progress of the family model, check the parameters by changing its values. As in the catalog, Fcu height is 275 mm. For model 921, I draw the line 275 mm from reference level. Now log the thickness of top part. Now I will model for Fcu below part. As the shape almost same like top one, let me copy the same element. In this copy model, we no need the support holes, so I am deleting this. Move 35 mm inside. Let's adjust the corner. Then lock the edge to edge. As I told you, for all Fcu models these edge dimensions are fixed. Then again check the parameters by changing its values. You can check this time one corner line is not moving as per parameters. In that case, let me delete this line and again draw the same. You can check now it is working as per parameter changes. Now let me draw the Fcu main body. I am assuming this main body edge and the bottom part edge is 15 mm as there are no dimension are given to the catalog. Now lock the edges with top and bottom part. You can check the 3D look of the Fcu. For keeping inside hollow, let me draw void inside. You can check this void cuts inside the Fcu. You can check as I did not lock this edge, Fcu mid part is not stretching along with it. So let me lock the edges. For this side also let me lock the edges. So now it is working when I am changing the parameters. Now let me draw the inlet of the Fcu. Now lock the edge to edge dimensions. Let me check the parameters again, whether it is working or not. So it is working. Now create Fcu height parameter h. So again I need to lock every edges. Now you can check height parameter is working. As I lock the bottom edge, the height is increasing only towards the top side. Let me adjust the connector in the proper location as per Fcu catalog. You can check connector is moving with the Fcu width parameter. In the same way, let me copy the same for another connector. Now have a look on the progress 3D view. To make a cut in the connector area, let me draw void again and lock the edges to the connector inside edge. Now check the progress 3D view. Now I am assigning the duct connector to the Fcu. Here I need new parameter connector width and connector height. Now make formula connector width, which is always 120 mm less for every Fcu model. Similarly for connector height, which is 40 mm less than Fcu height for all Fcu model. Now assign the same parameter to the connector. This connector should be in supply air system, as this is fan side, so below connector to be return air side. Now I am modeling grill part of this Fcu. You can check this element is not locked properly with edge to edge. So let me fix this problem. So now its all parameters are working. This time I am modeling fan parts of this Fcu. you can check fans are moving as per FCU parameters size changes. Now let me model coil and pipe connector part of this FCU. Now you can check chilled water connectors are moving as per parameters. This time let me model condensate water connection of this FCU. Now assign connector for pipes. Now all these parameters are working. Now to change material, follow the process. So now you can understand, in this process we can easily change material of any elements in the Revit. Let me open my existing mechanical project model where I want to place this Maker Fcu model. You can drag and drop this file into project file. When I am selecting this model, you can check there are no type family. For this, let me all instance parameter convert to type parameter. Then in the type name, create new type as per catalog data. So now you can understand that according to type change, family sizes are also changing. So now after replace the old model, all the types have been added to the family. So let me copy the Fcu side by side and assign to the different types. You should place these Fcu as per your design concept. As this video become more lengthy, so I plan to show the Fcu connection detail modeling in my next video. So by using one Fcu parametric model, I have created 6 different sizes Revit model. Now time to create share parameter in the same Fcu family model. For this, first let me create share parameter text file. So in this way, create the other share parameters. Now in this process you can add share parameter in the Revit family. Now to create schedule, go to schedule, select mechanical equipment. Add the parameter which I create for Fcu model. As in the equipment model 09 mkhs is common, I will filter by 09 mkhd. So now you can check quantity of these particular 6 maker Fcu have been created. Now time to add data to the table as per catalog. In this way, you can assign the data from catalog. In this video, I am not assigning the proper data, as this data will be based on project requirement and suppliers information. This video only to show you how to model a Fcu parametric model in Revit. The related Fcu duct connection and other pipe and electrical modeling I will show you in my next video. I hope you like this video. For more video, please do subscribe, like and share. See you in the next video. Take care. Bye bye.